So hey guys, today we are going to solve this XOR tree problem. I would be solving this problem and you can also try. The problem code is here 429A. Just type on Google, you will find it. I will be doing in some way, you will be doing yourself in some another way. Comment in the comment section below that which way did you solve it. If you were able to solve it in a better complexity, and how much time did you took. So from now I will be solving it on myself. You can continue to the end and check if I was able to solve it. Okay, now I will start. Okay, so what I understood from the question is, let's illustrate with this question itself. So it's given that it's a tree rooted at 1. So let's not just make it, oh, we can make it. Now it has a child 2 and it has a child 3 and 2 has a child 4, 5 has also a child 1. Okay, it's not a binary tree, it's just a tree. 6 has 2 are connected, 7 and 5 are connected, 8 and 6 are connected, 9 and 8 are also connected, and 5, 7 and 10 are connected. So initially the value at 1 is 1, 2 is 0, 3 is 1, 4 is 1, and 5 is 0, 6, 3, 4, 5, 6 is 1, 7 is 0, 8 is 1, 9 is 0, and 10 is 1. And what we want to make it is the difference. So at 4 we want 0, so this is one node which we want to change, and we want to change 5th, 6th, 7th node. What is it? 7th has 0, we want to change this to 1 by performing minimum number of operation. And in one operation we flip one node and all of the children, the next children are not flipped, and all the children in the even steps, like even depth from their parent, are flipped. So like if I flip this to 0, this at these both, all these at this level would always be changed, and all these at this level would also be changed. So I would be thinking of some way. I would be thinking of some way to do this thing. And let's see. The solution given is that four operations are required. I mean, two operations are required. First, we flip 2 and 7. These are really straightforward as they don't have any children. So we can directly flip them to get the desired result. Okay, so we need to just find the minimum number of flips required. Okay. Hmm. Let's take some another example which is somewhat easy to understand because this one was not that much good, I think. So suppose this has 0, 1, 0, 0, 1, 1, 0, 1, 0, 1 and 0. And if we want 0 here, okay, so how should we proceed? So first of all, what we can do is directly flip this, or so if we flip these, then all these also would be flipped. Then we have to do work to again flip them back. Is there some way to avoid these flips? So if we look at this, so all these levels are connected. So if one of them is flipped, all the others are flipped. And if we look at these levels, all these are also connected. So if we flip any one, then it's flipped. But the side is also important. If we flip this, then only this side will be affected, not this one. So we need to find some way that way. Hmm. There's some better way of doing it. I'm thinking about that. Because one thing which I'm able to think right now is that if we made some unnecessary changes, then we have to always flip the half of the children again to get them back on track. So we think what is the constraint is 10 to the power 5. Okay. So basically one thing which I'm able to say is at the highest level which requires to be changed. We don't need to change any of its parent, so that is for sure. So let's suppose this is the one which is part to be flipped. If we flip these, all these will be flipped. Again flip them back. These both level has some of that which wanted to be flipped. Flip these, and all these will be flipped again. And, okay. Since it's a tree, I'm thinking of something like this. Let's number this 1, 2, 3, 4, 6, 7, 8, 9, 10. So suppose if we did something to at 1, then how many of them would be affected? 4, 5 and 6. Suppose we did something on 2, then 7, 8 and 9 would be affected. Did something on 3, then only 10 would be affected. If we did something on 4, then no one would be affected. And if we did something on 5, none of them would be affected. 6, none of them. So last two level, no one has no issues of flipping, so we can just directly flip them in one move if required. But I think that we can even club them with some above moves. So I think we should be doing it from the top and and how many of them are possible? I don't think we will be able to do it. I think yes. So now this has to be flipped. So we'll directly go there. 4 has no effect of anyone. 5 and 6 also have no effect on anyone. Let me think. Can this be done? Okay, I think I need to take some help from the editorial now. Let's load the editorial. So here is the editorial. Let's now think. Oops, the editorial is wrong, I think, for this. There it is. It's a really long editorial. Okay, so this is the same which I just discovered, that we there is no point in making operation on some child until all the ancestors are fixed. Okay, this is a good observation. Oh, that's great. So what it's telling in this paragraph is that we should fix the root node, which is the first node. If it is not, as the only way to do fix that node is to by performing an operation over there. So then, okay, this is a great operation. So in this paragraph, it just says that after one and the children of one are fixed, we can go one layer down and fix them by doing operation there. So now, okay, this just says that the for any node x we have to first for satisfy all the ancestors, and then at x, if it is unsatisfied, then we have to make a operation there. Otherwise, if it is satisfied, then we can move on. So the complexity leads to order n square. Okay, so this was a great question. After reading the tutorial, but I realized that I was able to think only to this point. So now the thing is that we need not only this work to be done, uh, and also we need to make some class-like thing with the properties like initial value and initial value, the odd times, the even times, and the level. And while construction, we have to just initialize this to 0, this to 0, this to the input value, and level to the BFS or DFS, whichever we are doing, level. Okay. And while performing the operation from the top itself, we would be finding that if it is not satisfied, okay, if it is not satisfied and it is at suppose even level 0, suppose this is the tree, so this is level 0, this is level 1, this is level 2, and suppose we have some more here, this is level 3. So suppose at this level you found that some of this is not satisfied, so the if this was flipped or not, so odd even places how many times was flipped, we need to use that to find that what is the current state of it. So like if it was used even number of times, then it would be still initial value. If it was used odd number of times, then it would be flipped once, so not of initial value. And that value also we need to compare with the goal value. If it is the same, then we don't need to do anything, or if it is not the same, then we need to make another option and propagate below to the children with even times incremented by 1, and at this we would be checking for the odd times and similarly till the leaves. So basically first we need to construct this tree. Let's think now how would we approach this. So the class structure is pretty clean. We would be, suppose this is a node class, we would be having an array of node class of size n, definitely node class of size n plus 1 rather, because this is 1, and we will take this input array and out goal array and input array, initial array and goal array. Using this we will first construct this node array, and after construction we would be doing the operation. So now let's start and do it stepwise. It would be something really big, I suppose. And again this operations. Okay, copy this input here. Finish. Okay, so first of all we will be making the class structure. Let's define everything public. So what all properties would this be having? Initial value, odd times, even time, and level. So integer along init value, odd times, and it would be having even times, and it would be having, what was the last? Okay, the level. And we also would be making one constructor for this. The constructor would be taking initial value and the level. Okay, and then we will set init val to init, and this would level to level, and odd times would be 0 in the beginning, and even times also be 0. So this is how it would be. And now let's make this array. How much size is required? It's 10 to the power 5. So I think our node, let's make it capital. Here also it needs to be capital. Node of size 2, 3, 4, 5. Okay, and then let's make this construction, or rather I will make it locally first. And then okay.